Hello everyone! Today we're going to take a look at polygons and triangle sides and angles. We'll look for the interior and exterior angle measures in polygons, we'll sort the sides of triangles, we'll look for viable triangle side measures, and we'll list the range of possible values for the third side of triangles. So starting out, let's look at the interior and exterior angles in polygons. For example, let's consider a pentagon. Well, in a pentagon, I can see that it has 5 sides. So at the top of our chart, which you can draw just by making a tic-tac-toe board, honestly. 1 sum, interior, exterior, right? So you can sketch this really quickly whenever you need to. And inside of this chart, at the number of sides, we're going to write 5. Well, the one thing we need to know is that if I take all the exterior angles of a polygon, so if we make each of these sides a little bit longer, all of these exterior angles here are always going to add to the same number. All the exterior angles in every single polygon add to 360 degrees. The exterior angle sum, so the exterior angle sum is always 360 degrees. Well, I can see that if I have 5 sides, that 360 degrees is going to be divided into 5 equal pieces, right? 1, 2, 3, 4, 5. So if I take 360 degrees and divide it into 5 equal pieces, I know that the measure of one exterior angle would be 72 degrees. That's not so bad. Well, I know that if I were to look at one interior angle and one exterior angle, these two together are going to add to equal 180 degrees. Right? That's an addition, I promise. So if I take 180 degrees and take away the 72 degrees, what's left over is going to be the measure of one interior angle. And there are 1, 2, 3, 4, 5 interior angles, right? Same as the number of sides. So I'm going to take that 108 degrees and times it by 5 to get my interior angle sum. So 108 degrees times 5 is, and we're grabbing Desmos, we're plugging it in because it's always better to try it out instead of just listening to me. So grab your calculator, 108 times 5 is 540 degrees. One thing I want to point out, after I circle these 3 values, one thing I want to point out is that if you take these sums, if you add the sums together and divide it by 180 degrees, it'll always equal the number of sides. That's a nifty little shortcut that'll definitely help you out later. All right, so now let's consider a tessellation. The idea with a tessellation is tiling, right? Things that lay flat. So in order for it to work, all the angles around any point, for example, this point here, the angles must add to 360 degrees. So if I take 90 degrees, plus 60 degrees, plus 120 degrees, plus 90 degrees again, they have to add up to equal 360 degrees. Let's apply that to our first example. So in example number 1, the floor plan for a modern home is modeled by the composite of the regular nonagon, where I can see that word nona, which means 9, by the composite of the regular nonagon and triangle shown. What is the measure of angle JKL? So you go from J to K to L, so I can see what I'm trying to solve for is right here. This is my X. Well, I can see that this angle is at the vertex K, so if I can solve for these two unknown angles, then I can see what X will add up to equal 360 because they're all tiled around that point. So first let's draw our chart to work with the nonagon. So drawing our chart. Oof, let's give ourselves a tiny bit more space. I'm so sorry, I want you to be able to read it. So giving ourselves a little bit more space, we'll draw our tic-tac-toe board. Right. Interior, exterior, 1, and sum, and the number of sides in a nonagon is 9. So starting with our exterior angle sum, it's always 360 degrees. So I take my 360 degrees and divide it into 9 equal pieces. And when I take 360 degrees divided by 9, I get 40 degrees. Right? Well, that's okay for an exterior angle, but what I really want, what I really need, is this interior angle right here. That way I can see what tessellates around the point K. So I'm going to take 180 degrees minus that 40 degrees to find out that one interior angle in a nonagon will be 140 degrees. Lovely. Now, there's a shortcut with triangles because we know them a lot better. I know that all the angles in a triangle, the three angles in a triangle, excuse me, sum to 180 degrees. So if a triangle has all its sides the same length, that means all of its angles are also going to be the same measure. So I'm going to take that 180 degrees and divide it into 3 equal pieces to figure out that that angle is going to be 60 degrees. So because 60 degrees, 140 degrees, and x tessellate around point K, I can take 140 degrees plus 60 degrees plus x and equal it to 360 degrees. So if 200 degrees plus x is 360 degrees, then x must be equal to 160 degrees. Remember that you can take away 200 from both sides. We got this. So looking at example number 2, a polygon is shown, and we need to find the measure of angle u. So our angle u is the angle at the vertex u, so we're going to put our x there. And do you see how we have 2 arcs here? That means that angle v is also x. I know that this square means that this is 90 degrees. And the fact that this arc matches the other means that both of these are 150 degrees. But it's not enough just to know what I need and how they're labeled. I need to know what all these angles add up to. So because these are interior angles, I need to make my chart to get my interior sum. So first off, I'm going to write the 360 degrees that I always put every single time. And then for this chart to work, I have a picture so I can get the number of sides. 1, 2, 3, 4, 5, 6 sides. So I can take my 360 degrees and divide it into 6 equal pieces, which gives me 60 degrees. I can take 180 degrees minus 60 degrees to get my one interior angle, 120 degrees. And then because there are 6 angles inside, I take the 120 degrees, times it by 6 to get 720 degrees. What this means is that all the angles inside of my shape, so x plus 90 plus 90 degrees, not forgetting its degrees, plus 150 degrees plus 150 degrees, all those interior angles are going to sum to equal 720 degrees. So 2x plus 90 is 180, 150 plus 50 is 300, so 480 degrees is going to equal to 720 degrees. So I'll take away the 480 from both sides, minus 480 degrees. I get that 2x is 720, take away 480, 720 take away 480, 720 take away 480 is 240 degrees. Because then I can divide both sides by 2, and I find that my missing angle is 120 degrees. Now let's take a look at some triangles. So when we are sorting angles and triangles, the longest side, right, the longest side is across from the largest angle. What that means, when I say across from, you could think opposite or not touching. So the longest side is not touching the largest angle. The shortest side is across from or not touching the smallest angle. So looking at example number 3, 3 boys are in a field flying kites. Viewed from above, the angle at Kyle K measures 45 degrees, and the angle at Jake J measures 65 degrees, which shows the distance between the boys in order from least to greatest. So for this to work, we really need to find what is the value of angle 11. Well, I do know from before that all the angles in a triangle sum to 180. So I'm going to take 60 degrees plus 45 degrees plus what I don't know and set it equal to 180 degrees. So 60 plus 45 degrees is 105 degrees, plus something will equal to 180 degrees. So if I take away that 105 degrees from both sides, I find that the angle I am missing is 75 degrees. So at angle L, I'm going to write in the number 75 degrees. One technique you can use is then sorting the numbers from least or small to large. So 45 degrees is the smallest number, 65 degrees is in the middle, and 75 degrees is the largest. 45 degrees is at K, 65 degrees is at J, and 75 degrees is at L. Well, I'm going to take a second and I'm actually going to draw a circle and I'm going to cover up what I'm thinking of, okay? So if angle K is the smallest, right, then the side it does not touch would be LJ. So I know LJ has to be my first one. So remember that getting rid of bad answers should be our first step. We can cross out the two that do not match. Well, moving the circle around, ooh, can we move it? Is he, yep, there he goes. So moving the circle around, I see that J is in the middle, so I'm going to cover up my J, and what's left behind is LK. Sorry about that. What's left behind is LK. So I instantly know that answer D is my correct choice. Awesome. So when we're determining if a triangle exists, we're going to add the small side and the medium side and make sure it's greater than the longest side. So in example number 4, John wants to make a triangular garden. I have to determine which of the following are possible, which of the following would work. What that means is that 3 won't work and 1 will. This is a useful testing piece of knowledge because now I can look for patterns. Even if I forget how to do this, I can say, well, 3 of them absolutely won't follow a pattern and 1 of them will. So looking at the first, I'm going to take my small side plus my medium side. So 6 is small and 8 is medium. So I'll take 6 plus 8 and check to see if it is greater than 10. Well, 6 plus 8 is 14. 14 is greater than 10, so it definitely works. So right now, I'm really thinking my answer is going to be A. But we were talking about patterns, so I do want to do a couple more. These ones are pretty fast. So my small and my medium, 4 plus 5, is that greater than 10? 9 is not greater than 10, so no. 8 and 12, 8 plus 12 has to be greater than 20. 20 is not greater than 20, so no. And lastly, 6 and 6. This falls into the same trap. 6 plus 6 is not greater than 12. It's equal to, right? And so that's why A was my only correct solution. Looking for patterns is a great way to try some of these multiple choice questions. Right? Now, we'll look at finding the possible third side of a triangle. We will add and subtract the two sides we are given, and the third side must be between the two numbers. So two sides of a triangle are 7 and 4. Let's switch colors so it's a little easier to read. Which measure could not be the length of the third side? So first we'll add and subtract the two sides. So 7 plus 4 is 11. 7 minus 4 is 3. So our third side must be between the numbers 3 and 11. Okay, 8.5 is between 3 and 11. 12 is not. Notice that if I made a number line where I had 3 and 11, 8.5 would be between them, but 12 would not be, right? So if I think about, sorry about that. So if I think about my solution as being between 3 and 11, as being between 3 and 11, 12 is outside of that range. Okay, 4 is also outside of that range. Oh, wait, I can do numbers. 4 is between 3 and 11, so he does work. And 10 also is between 3 and 11, so it works. The odd man out would be B. 12 centimeters is not between 3 and 11.